Hi students, in this video we're going to cover the chain rule. So we're not going to actually prove the chain rule in this video, we're just going to use the fact of it immediately. So the chain rule is when we have a composite function. And from pre-cal and algebra 2, we should know that composite functions have this form like h of x is f of g of x, where we have a function substituted inside of another function. An example could be if we have like f of x equals x squared plus 2x minus 1, and I ask you what is f of 3x plus 1. Well, to do that operation, you'd have to do 3x plus 1 squared plus 2 times 3x plus 1 minus 1. Because everywhere we have an x, we're going to replace it with the expression 3x plus 1. So if we wanted to do the derivative of this equation, we would use something like the chain rule to do so. So the chain rule says that if you have a composite function, then its derivative is the derivative of the outside function times the derivative of the inside function. In the inside function, we're going to consider the function whose operation, if you substituted in a value, would have to be done first. And the outside function is the function whose operation would have to be done last. Now for us, we're only going to write this as two functions, but you can write many compositions using more than two functions. So for example 1, we're not going to actually do any derivatives. We're just going to rewrite the function as a composition where we have f of g of x. So for letter A, we have 2x minus 3 cubed. So our two functions are, we're going to multiply something by 2, subtract 3, and our other function is that we're going to cube it. So our g of x function is going to equal 2x minus 3. So then that means that our f of x function is the last thing that we do, which is going to be to cube that value. So that's going to be x cubed. So if we rewrite this, we're going to have h of x is equal to f of g of x, and we're going to see if that actually makes sense. So now f of x is x cubed, so f of g of x is going to equal, so we're going to take in f of x, everywhere we have an x, we're going to replace it with 2x minus 3. So that's going to give us 2x minus 3, but the rule for f of x says we need to cube. So we get 2x minus 3 cubed. For letter B, we're going to do the same thing where our two functions are, we have the square root of cosine x plus 1. So the inside function is going to mean we take the cosine of an angle and then we add 1 to it. So our g of x equation is going to be cosine x plus 1, and our f of x equation is going to be the square root of x, the square root of whatever we just took the cosine of and added 1. So when we rewrite this, again, we're going to have h of x is f of g of x, and in this case, f of g of x is equal to, is just going to be the square root of cosine x plus 1, because we've constructed our functions that way. So you pause the video and see if you can do C and D. For D, I'll give you the hint that this is the same as the sine of 2x to the 7th power. All right, so if you're rejoining me, the first thing that you would do is you would evaluate whatever x squared minus 5x plus 1 is. So that's going to mean your g of x equation is x squared minus 5x plus 1. And then your f of x equation is going to be the sine of some angle. So if you rewrite this as f of g of x, then that's going to be the sine of g of x, and we know g of x is actually x squared minus 5x plus 1. So that works exactly like we thought it did. So you know what, actually, if we go back to part B and part A, we can add one more layer to that. So for B, when we wrote this as f of g of x, more appropriate would have been to initially say that, well, f of g of x is going to be the square root of g of x, which would have given us the square root of cosine x plus 1. And then if we do something similar for option A, we would have gotten g of x cubed, which would be 2x minus 3 to the third power. So then for D, so the first thing that we're going to do is, like, you know what, actually we can write this, let's try writing this one as 3 functions instead. So imagine then the first thing that you're going to have to do is multiply an angle by 2. So we'll use a new letter. We'll say we have FG. Let's go with K. So K of X is just going to be you multiply something by 2. Then we'll say G of X is after you multiply that thing by 2, you take the sine of it. So that's going to be the sine of X. And then F of X is the last thing that you do, which is raise that thing to the 7th power. So those are our 3 functions. So if we wrote this as a composition of functions, we could say h of x is equal to f of g of k of x. And so then if we rewrite that, so then f of g of k of x, well, that's going to equal f of g of, so k of x is 2x. So you're really looking at f of g of 2x, which is the same thing as, so in the f function, we're going to have g of 2x to the 7th power. But then what is g of 2x? So g of 2x is going to be the sine, and then in the place of x, we put 2x, so we get 2x to the 7th. And remember, when you see a trig function raised to a power, it means the function is raised to the power, not the angle. So we generally put it on the trig function and not at the back, just so there's no confusion. So this is actually the same thing as sine to the 7th, 2x. So like once we understand the concept of what's inside and what's outside, we can actually start doing calculus to get our derivatives. So for example, 2, we're going to find the derivative of each of these functions. So for part A, we have h of x is 3x squared plus 2x minus 1 to the 4th. So for our derivative, so h prime is going to be, so the derivative of anything to the 4th power is 4 times that thing to the 3rd power. We're not going to change the inside, but now we're also going to multiply by the derivative of the inside. So that's going to be 6x plus 2. Remember, the derivative of constants is 0. So let's go back up here and look at the chain rule just one more time. So if h of x is this composite function, then its derivative is the derivative of the outside times the derivative of the inside. So that's what we're doing. And if generally there's not going to be much to simplify. I mean, we could say this is 4. We can make it look better. So 4 times 6x plus 2 times 3x squared plus 2x minus 1 cubed. But we don't actually need to multiply that out. For Letter B, we have the cosine of 2x squared minus 1. So again, our inside function is the 2x squared minus 1. Our outside function is the cosine. So the derivative of cosine is negative sine. And for trig functions, unless we're applying an identity, we're not ever going to change our angle. So the derivative of cosine is negative sine 2x squared minus 1. But then we need to multiply by the derivative of the inside function, which is 2x squared minus 1. The derivative of 2x squared minus 1 is 4x. So in a rewrite step, we're going to have negative 4x times the sine of 2x squared minus 1. And uh, we would never distribute the 4x to the angle. That would be inappropriate. So don't think that we do that. We always just move the expression at the back generally to the front. For letter C, we have this function f of x is the sine of x squared plus 10 to the 5th power. What's important here is that the x squared plus 10 is what's raised to the 5th power. So when we do our derivative, we're going to have f prime of x is equal to, so our inside function is x squared plus 10 to the 5th, and the outside function is just a sine. So the derivative of sine is going to be cosine. Remember, we never change our angle, so that's x squared plus 10 to the 5th. But then we need to multiply by the derivative of our angle, which is x squared plus 10 to the 5th. So that's going to be 5 times x squared plus 10 to the 4th. And then we have to multiply by the derivative of x squared plus 10, which is 2x. So we use the chain rule twice here. So in a simplification step, we would get 5 times 2x is 10x. So 10x, and we'll put x squared plus 10 to the 4th times, we'll just write cosine, we don't need to put it in parentheses. So cosine x squared plus 10 to the 5th. So again, if we review that, the inside function was x squared plus 10 to the 5th. The outside function was the sine of, we'll say the sine of x, or the sine of an angle. The derivative of the sine of an angle is the cosine of that angle, and then we multiply by the derivative of our angle. So what I'm underlining, we'll put this in a box. So this is the derivative of x squared plus 10 to the 5th power. Oh, we'll put a bracket on there. So all of this is just the derivative of the angle. For part D, it's very similar, but the power is in a different place. We have y equals sine 5th x squared plus 10. So if it helps you, it's better to write this as the sine of x squared plus 10 to the 5th power. And so now our inside function is the sine of x squared plus 10. Our outside function is something being raised to the 5th power. So our derivative is going to be, well, the derivative of anything to the 5th power is 5 times that thing to the 4th power. So we're going to have 5 sine x squared plus 10 to the 4th power. So that's the derivative of the outside part, the 5th power. And then we're going to multiply by the derivative of what's on the inside. What's inside is the sine of x squared plus 10. And so then the derivative of sine is always going to be cosine. So we have cosine, remember, we never change our angle. So cosine x squared plus 10. And then inside the cosine, we have the x squared plus 10 part. And the derivative of x squared plus 10 is 2x. So if we simplify this, we get 10x sine to the 4th x squared plus 10 times the cosine of x squared plus 10. Compare that answer with what we got for part C. So for part C, because the sine wasn't raised to a power, when we took its derivative, we got just a cosine. But for part D, because the sine was raised to a power, we're going to have another sine left over. We're going to have sines left over when we do the derivative, and we have to also multiply by the derivative of sine and get cosine. For letter E, we have y equals x divided by x squared minus 1 to the fourth power. So here we have an inside function that's x divided by x squared minus 1, and our outside function is raising that to the fourth. So using the chain rule, we're going to get y prime is 4 times x divided by x squared minus 1 to the third power. That's the derivative of the fourth power part. The inside is going to require that we do the quotient rule because that's how we derive x divided by x squared minus 1. So remember, the quotient rule is the denominator multiplied by the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the denominator squared. So if we rewrite this, so let's do a rewrite on something. This term here is the same as 4 times x. I'm sorry, you have an eraser. So the term underlined in red is the same as 4x cubed divided by x squared minus 1 cubed. So we'll just keep that in mind when we're simplifying. So when we simplify our derivative, we're going to have 4x cubed divided by x squared minus 1 cubed, and then it's going to be multiplied by, so we're going to have x squared minus 1 minus 2x squared. So x squared minus 2x squared is negative x squared. So times negative x squared minus 1 divided by x squared minus 1 squared. So in a final rewrite step, this is 4x cubed times, we can actually factor out a negative. We'll say like negative 4x cubed times x squared plus 1 divided by x squared minus 1 to the fifth power. All right, so in this problem, we use the quotient rule and we use the chain rule. The answer to the question of Mr. Martin, when do I use the chain rule? All the time. The quotient rule and product rule are situational based upon if we have quotients or products, but we always are going to use the chain rule. So now example 3 is we're going to have a table of values and we're just going to find some derivatives based upon a function that we're given. So take a moment to look at the table. All right, so for part A, we have h of x is f of g of x, and we need to find h prime of 2. To find the derivative evaluated at 2, we first need the derivative function. So h prime of x is, so derivative of the outside function, so f prime of g of x multiplied by the derivative of the inside function. This is the literal definition of the chain rule. So h prime of 2 is going to equal f prime of g of 2 times g prime of 2. And so G of 2 is equal to 1. So we're looking at f prime of 1 times g prime at 2 is 4. So f prime of 1 times 4 is going to equal, let's see, f prime of 1 is actually 1. So 1 times 4, that's going to equal 4. So again, all we did was use the chain rule to find our derivative, even though we don't actually have any sort of functions to do so. We just have the concept of a function. For part B, I copied and pasted the table just so we can see it because we're going to do more of these. So we have m of x is f of x plus 1 cubed, and we need to find m prime of 3. So we need a derivative first. So m, oh, is it erasing? M, why is it doing that? It was being weird earlier. Hold on just a moment. So m prime of x is going to equal 3 times f of x plus 1 squared. And then, so that's the derivative of the outside part, the thing cubed. But then we also need to multiply by the derivative of the inside. The derivative of f of x plus 1 is just f prime of x. And so m prime of 3 is going to equal 3 times f of 3 plus 1 squared times f prime of 3. That's going to equal, let's see, f of 3 is negative 1. So negative 1 plus 1 is 0. 0 squared is 0. 3 times 0 is 0. 0 times f prime of 3, which is 2, is going to be 0. So that's going to be 3 times 0 squared times 2. So that's going to equal 0. Cool. Option C, or letter C. We have c of x is f of x squared divided by g of 2x. So, and we need, I'm sorry, and I didn't put what we need to do. We're going to say find c prime of, we'll go with 1. All right, so we'll have c, so c prime of x, this is going to require the quotient rule. So the quotient rule is the denominator, so g of 2x multiplied by the derivative of the numerator. So that's going to be f prime of x squared, chain rule, and so then multiply by the derivative of the inside, which is 2x. And then minus the numerator, which is f of x squared, times the derivative of the denominator, which is g prime of 2x multiplied by 2, because derivative of the outside times the derivative of the inside, and all divided by g of 2x squared. If you want to clean that up a little bit, feel free to do so. We would get 2x g of 2x f prime of x squared minus 2 g prime of 2x times f of x squared. The only thing meaningful that we could actually take out is maybe a 2, but we're not going to actually worry about that. So g of 2x squared. Let's get a little bit of space here. Oh, let's undo a couple of things. Excuse me. Oh, did it again, Mr. One. All right, we'll just write off into the margins. So we'll section off this space for the rest of C. So we need to substitute in 1. So C prime of 1 is going to equal 2 times 1 times G of 2 times F prime of, well, 1 squared is 1, minus 2 times G prime of 2 times F of, well, 1 squared is 1, and all divided by G of 2 squared. So when you're showing your work, it's going to be helpful if you show me this step, because even if you make some arithmetic error, I know that you know exactly what to do if you show me this step. So then 2, so G of 2 is 1. So you're going to have 2 times 1 times 1. And then F prime of 1 is also 1. So this is just going to be 2 minus G prime of 2 is 4. So 2 times 4 is 8. F prime of 1, F of 1 is negative 2. So actually, let's write this down. So we said 2 times G prime of 2 is 4, and F of 1 is negative 2. So we're just multiplying all of those. And then G of 2 is 1, so divided by 1 squared, that's what, 2 minus 16. So 2 minus negative 16, so that's 18 divided by 1, which is 18. All right. And the last one is letter D. We have S of x is the sine of pi over 4 f of x times g of 2x. So the derivative, and we'll say, well, let's evaluate this at f of, have we used 2? Yeah, we'll say 2. We'll say at x equals 2, we want to find the derivative. So s prime of x is going to be, so here we're going to have to do the product rule. So the product rule is going to be the sine of pi over 4 f of x multiplied by the derivative of g of 2x. The derivative of g of 2x is g prime of 2x times 2. So that is our derivative for the g of 2x part. I want this erased. There we go. I need some more space. So then we're going to have plus g of 2x multiplied by the derivative of sine pi over 4 f of x. Well, the derivative of sine is always going to be cosine. So cosine pi over 4 f of x, but then multiplied by the derivative of the inside. And the derivative of pi over 4 f of x is pi over 4 f prime of x. And that is it. So if we simplify, actually we'll need to simplify. So we'll say like s prime of 2 is going to equal the sine of pi over 4 times f of 2. Now f of 2 is 3, so we'll actually write f of 2. We got space. So f of 2 times g prime of 2 times 2 is 4. So g prime of 4 times 2, then plus g of 4 times the cosine of pi over 4 times f of 2 times pi over 4 f prime of 2. And in our final step, f of 2 is 3. So we're looking at the sine of 3 pi over 4. 3 pi over 4 is in quadrant 2. and its sign is the square root of 2 divided by 2. The g prime of 4 is 8, and so 8 times 2 is going to be 16, so we're going to have square root of 2 over 2 times 16, plus then g of 4 is 11, so plus 11. F of 2 is 3. So the cosine of pi over 4, so the cosine of 3 pi over 4 is negative square root 2 over 2. So I want this to move. This thing is, why is it, won't let me get out of this box for whatever reason. There we go. I was just out. Okay, yeah, we're back. My apologies. All right, so g of 4 is 11, and f of 2 is 3. So we're really doing the cosine of 3 pi over 4, which is negative square root 2 divided by 2. And then we have times pi over 4. And then f prime of 2 is 4. So times 4. So if we simplify, we're going to get 8 square root 2. And then pi over 4 times 4 is going to be pi. So we're going to say minus 11 pi square root 2 over 2. So that's our final answer. Now again, our only step of calculus was really this one. Everything else was just simplifying and using that table. So that's going to conclude our video on the chain rule. Quick review is, hold on, it's got to load. So here we go. So quick review is, let the page load. Come on, man. Where is, all right, so the whole thing just, how did it disappear? It's crazy. So I guess I can just write this. It's not gonna let me write though. Oh, here we go. So now it wants to load. So here, I'm sorry, my apologies. So if we have a composite function that is, again, h of x equals f of g of x, a function with a function inside of it, then its derivative is the derivative of the outside function multiplied by the derivative of the inside function. The thing that we want to make a note of here is never change the inside function. Never change the inside function. So look, in all of our examples where we did derivatives, the inside function stayed the same. For A, we didn't change the 3x squared plus 2x minus 1. For B, we didn't change the 2x squared minus 1. For C, we didn't change the x squared plus 10. For D, in this case, it was sine to the fifth. We didn't change the sign, and we also didn't change the angle. For E, we didn't actually change the x divided by x squared minus 1. We used the property of exponents that allowed us to cube both, but we didn't really change it. And then for all of these examples with the functions, we never changed the input, the actual inside function. It always stayed the same. And that's the important part about the chain rule. Do not change the inside. All right. Hopefully the video was helpful. I'll see y'all in class where we'll do some practice.